Hello, I'm going to make a series of videos on what is called unit circle trigonometry. And this is the first of a number of lessons. In this lesson, I am going to do the first thing, which is to redefine what an angle is. You've probably learned and known for many years what an angle is from geometry. It's two rays. It's just two rays. So here is an old definition of an angle. Your old definition of an angle was you just take two rays which start at a vertex and go out. They are sort of half of lines. And this is a ray and this is a ray, so two rays make an angle. I'll also say that if this angle, let's say this angle is 85 degrees, it kind of looks like that, I want you to notice that the angle measure tells you how open the angle is. How open. I'm putting that in quotes, but it should be a clear idea that you understand. It's how open the angle is. Now, before we move on, I want to address a misunderstanding that lots of students have, even when they're thinking about the old definition of angles. When I ask a student, what is the angle here? They often say the angle is the stuff on the inside. It's like this region inside. And I want to be clear, that's incorrect. The angle itself isn't that stuff on the inside. What the angle is it's just these two rays. What the stuff on the inside is that people are thinking about, that's related to the space that the measurement is about. It's how open it is. So let's be careful that we understand what the angle is. It's just two rays. And the number that goes there tells you how open they are. That's the old definition. Here is the new unit circle definition. Unit circle trig definition of an angle. And it's similar, but it's crucially different in some ways. Pay careful attention to this and start to really to think about this whenever you draw an angle moving forward. It says this: every time that we draw an angle from now on, we're going to choose to draw the x and the y axes of the coordinate plane. We didn't do that over here because we don't usually do it in geometry, but we're always going to do this in unit circle trig. We're also going to have two rays, but one of them is actually going to be defined differently than the other one. That wasn't true over here. Here it's just two random rays. It's not like one of them is, more or less meaningful than the other one. But in the new definition, there's going to be two different rays again, but they're going to be different. The first one is going to be called the initial ray. And initial just means first, so that makes sense. And it is always, always, always going to be drawn on the x-axis pointing in the positive direction with its vertex, its endpoint, at the origin. This second ray, I'll make a different color for that one, put it in blue. The second one is going to be drawn from that same vertex, of course. And I'm drawing something roughly like this. It's a little bit smaller, maybe not 85 degrees. I'm drawing it over here. This one is going to be called the terminal ray. And I'm putting them in different colors for a reason. Something very important for you to think about is to imagine that this term initial and terminal actually means something about time. They mean something conceptually about an amount of time that has occurred. This initial ray you should think of as having literally been put there first. And then the terminal ray, I don't want you to think about it just appearing. Don't think of it just like being put there. Instead, you've got to see that the terminal ray in your mind should be thought of as having started right on top of the terminal ray and having rotated to where it is. In fact, there's always going to be a symbol in the diagram of these angles that captures that. Now, I've made a little arrow here just telling you that that's the terminal ray, but that was just telling you where it was. I'm going to erase it. This arrow right here is always going to be in these pictures. Notice that it doesn't go in two directions. I didn't make it like this. I'm not going to do that because there is an implication here of movement. You have to think of the initial ray as having that first position, and then we rotated. It's the right word, isn't it? We rotated that second ray to its new position. That is called an angle in standard position. It's a technical term, standard position angle. And now the most important part of this is I need to think about how to capture this old idea of an angle measure. Now I'm going to put an angle measure in there. Maybe it's this one's smaller. Maybe this is 65 degrees, let's say. And I'm even going to give a symbol for it. I'm going to write this variable here. It's the Greek letter theta, T-H-E-T-A. So theta. And that is the standard letter that we're going to use for an unknown angle, or one that's known. Here in this case, it's 65 degrees. But you want to get used to that. And all it means is an angle measure. 65 degrees in this context is not actually just telling us this. It's not just telling us how open the angle is. It's also telling us how far it has rotated from its original position. And so what we're going to say is that the value of theta tells us in degrees how far the terminal ray rotated from the initial ray. But here's a complicating thing here. I want you to notice that there's actually two different directions that we could have rotated this initial ray by 65 degrees. We could have either rotated it this way, or we could have rotated it that way, 65 degrees. And we'd like some way of capturing which is which. And I will say that for positive 65 degrees, for positive values of theta, what we're going to say is that the rotation is this way. Rotation is counterclockwise. I know that's a complicated thing. Many students go, wait, what's counterclockwise? But you've got to get used to that. Sorry, so if I can get that into the screen. That's a complicated idea, but it just means going in the opposite direction the hands go on a clock. It's that way. And so the opposite direction, erase this now, negative values are clockwise rotations. So let's do one example, and then we'll be able to go on to the second part of these videos. Let's do an example. Sketch in standard position a new angle theta that's equal to, let's say, negative 50 degrees. Now, I want to be really clear. If this had been a regular geometry class before you learned any of this stuff, that would be a nonsensical number. It would make no sense. If somebody said, hey, make a negative 50 degree angle before you learned this that I'm introducing now, you should have very legitimately said to them, what are you talking about? There are no such thing as negative angles. But because of this new definition, it's actually a very clear thing. Oh, it actually does exist. Negative angles do exist. It's just which way you rotate. So all you do is you draw the x and the y axes. You always do that. You always draw the initial ray, and I'm just going to keep going with red here for the initial ray. You don't have to write initial ray. It's understood. And the terminal ray, you say negative 50, think of a rotation. Because starting on there, negative means clockwise, down. And so I rotate down 50 degrees. You just kind of eyeball it, looking past halfway. And you have to draw this arrow. And there is theta equals negative 50 degrees. Notice that with this new definition, you can actually sketch angles of any number. I could give you numbers that you never would have thought of as legitimate angle measures now, and they are now. If I said something bigger than 360, if I said sketch an angle that's 390 degrees, it used to not make any sense, but now it does. 390 degrees would just mean start on the initial ray go counterclockwise, 90, 180, 270, 360, another 30 would be 390. And you'd make an arrow going all the way around. I'll do some more of this in the next video, but this is a crucial idea, and make sure that you start to fold it into your own understanding.